In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in prego, contra nequitiam et insidias diaboli, est presidium. Impere illi Deus, supplices te pregamo, tuque princeps militiae celestis, Satanam, aliosque spiritus malignos, qui ad perditionem animarum ervegantur in mundo, divina virtute in inferno deterrere. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. All right, take out your notes, please. One thing I want to do today, I'm going to give you hopefully some time to work today. I want to cover again the notes on division. There is one more assignment we're going to be giving for multiplication. So homework number 9E as an Egbert is going to be due Friday. So there's no long division yet. I would like to have a good 2 or 3 days worth of notes under our belt for long division before we actually try doing problems. Forecast. I might as well just put these up here now. Homework number 9, alpha's in Franklin. That's going to be due on Monday. 9G is going to be due on Tuesday. And that is the last homework of the chapter, which means there is a chapter test coming up next Friday. There's homework, the last homework will be due on Tuesday, and that'll be pretty much the last homework you have for the better part of the week. Correct. Your homework will be to study for the test. So chapter 9 test is going to be on Friday. Please God, I'm not forgetting any sort of like special schedule or something that'll train wreck that. Also, for people who have not had me before, which is probably everybody, I run a practice test for every test I have. So you'll have a good shot of what's coming up. Example, the last homework is on Tuesday of next week. So that means Wednesday would be the chapter 9 practice test. The way I run that, we're going to take it the entire hour. We're going to pretend it's a real test. And I will not grade it. It'll be for your, I will go through the answers and what have you on Thursday. And then we will go through any questions you have on Thursday. The test on Friday will look very, very much like it. So there should be no surprises when the test comes. I'm obviously going to change the numbers. So it's like, don't memorize the test in hopes that you're going to get 100%. It doesn't work. But so homework until next Tuesday. Then Wednesday, we take the practice test in class. So be prepared with the pen, pencil, blah, blah, blah. There will not be calculators on this. Thursday, we go over the practice test, answer any questions we can. If there are any remaining questions, catch me outside of class or email me or something. And then Friday will be the actual test. Okay? So that means after Tuesday, yeah, you don't have any, it'll be pretty much a week before you get the next homework. Merry Christmas, early. Questions on that? Does that make sense? All right. I do want to take a couple minutes. Peter Claver is actually one of my favorites. He's a saint from hundreds of years ago. I think it was the 1700s. He was one, he was working on a dock at one point. I think he had passage on a particular ship. And he saw the slave trade was in full swing. And I don't know if you've heard about the stories behind it, but it was absolutely horrendous. They would take human beings and pack them into a ship so tightly sometimes that they couldn't even lie down. They would just pack them in so that there's like, if everybody crowded to one side, you could probably get a few people to lie down. Otherwise, there would be people passing out from the heat, the stench. There was no place to go to the bathroom. They just, and they were on the ship for a month or two. The heat was incredible. The stench was incredible. A number of people died. They just expected it. They just treated people like cattle. They did this. They just, well, you take slaves, about 30% of them are going to die. Just like they say 30% of the cows are going to die on the ship. Wow. Peter Claver was I believe he was a priest at the time. He came upon this, and he saw the conditions, and he was on the ship, and he was absolutely horrified. He went to the captain And he knew he couldn't get the captain to, let them go. But he said, can I please go down there and at least minister to these people? Most of them, they did not speak English. Actually, Peter Kleiber didn't either. I think it was Italian or something like that. But it didn't speak any language that Peter Kleiber spoke. And the captain said, oh, Father, you have no idea what you're talking about. It's like, it's horrendous down there. The heat might kill you. And he said, exactly. He said, if these children of God down there can suffer that, then so will I. So do whatever you want. So Peter Kleiber went down there. The stench was so horrible. Peter Kleiber would go down there. He'd stay as long as he could. And then he would go up the ladder, lean over the edge of the ship, and throw up. His entire stomach empty, and then he would go right back down. The guy was amazing. He went down there, and he would stay with them. He would visit them every day for 8 hours or something like that for weeks and weeks. He would try with symbols and things and gestures to try and teach them something about Jesus, about how there is a life after this life where all wrongs will be made right. And he managed to capture them. They were so struck at the fact that he was being kind to them. He got a few people on the ship to help him. They went downstairs. There were people who were sick and dying, and he went down there and he, with a bucket of water and bathed their wounds and such. Put some, got some it was sort of like incense to cover up some of the stench, and then taught them all, sort of mostly by symbols, and then taught them a little bit of his language, what baptism was. And he said, if, really, really simple language. I said, if you believe in God who sent Jesus, who died for us, who loved us so much that he died for us, and if you get washed with this water that comes from him, you will be in heaven with him forever. And hundreds of people were baptized by his name. Over the course of his life, thousands upon thousands. It's an utterly amazing man. So read up on him. There are lots of other stories on him. All right, move back to math. Division. Right. Let me try that again for the camera. There. Again, I'm going to kind of review, especially for the people at home. We've got, I'll try another one. I think that'll work. Please. Go ahead and write this down. 23 divided by 479. Or 479 divided by 23. Way back whenever we learned this first, we kind of went on automatic pilot and said, how many times is 23 going to 47? Blah, 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 blah. Let me slow you down. I won't be as long as last time, but I'm going to slow you down. 23, the very first step that we usually skip because we're so good at this, 23 goes into 4 how many times? Go. 0. 23, a 2-digit number can't possibly go into a 1-digit number. Is this going to be 0? I'm going to put a phantom 0 here because you usually don't even write it. But it's 0. Does that make sense so far? When you try to do 23 into 4, it doesn't happen. Okay, so 23 into 47. Way back when, we didn't know how to do 2-digit division or 2-digit anything. What your brain does, this is actually true, it makes a guess just using the first number and the first number. It just takes a quick glance and says, how many times does 2 go into 4? And then makes a guess. Sometimes the guess is too big and you have to scale it back. And your brain does that in a couple of milliseconds. Sometimes it's good enough. Watch what happens. And I'm gonna slow this down to the point of being absolutely silly. Your brain is saying, how many times does 2 go into 4? And everybody says, 2. I don't know. Let's find out. How many times does 2 go into 4? That's a division problem. 4 divided by 2? Okay, yes, I believe you. What do you do with the 2? That you put up here. It's like a division problem. What do you do with the 2 now? You multiply it by 23, but I don't know how to do 2-digit math. All right, so do them one at a time. 2 times 2 is 4. 2 times 3 is 6. Again, seems silly, yes. There's a reason, and we saw a hint of the reason yesterday. at this point, people want to say, subtract the 46. Yeah, kind of, sort of, you. But I hate subtraction with a passion, therefore, I'm going to kill subtract. Here's subtraction. I add the opposite. 10 minus 3 is really 10 plus the opposite of 3. 10 plus negative 3. Here, add the opposite, but I can't do two-digit math. It's too hard for me. I'm going to do these individually. Add the opposite of 4 and the opposite of 6. I'm going to treat them as single numbers. Still good with me so far? So, teeny weeny little math problems. Cancel. So 4 plus negative 4 cancels at 0. 7 plus negative 6 is 1. All right. What do we do now? Somebody help me out? Go. Bring down the 9. Question, how many times does 23 go into 19? None. 0. So, I won't even do this over here. Because that's 0 divided by blah, 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 blah. So, what do you do with the 19? Yeah.
Bring it over and you put it over the 23.
Yeah, 19 23rds. What do you not do? Yes. Yeah, do not do R19. I know there are teachers in the past who did that. They meant well. God love them. I hope their place in heaven is high. But take R19 like a little squishy bug, drop it on the, hold it in the grass, not here, don't squish bugs in my carpet, and go squishy, squishy, dead. Okay, R, no more. All right, I do want to point out one last thing. Technically, and this is something we can highlight in algebra, like just a random number, 3 1/3. We pronounce that 3 and 1/3. Guess what the and means in math? Isabel. My goodness, I'm so sorry. I'll do it over here soon.
Can you repeat the question?
Oh yeah, 3 and 1/3. The word and means something in math. What do you think, just off the top of your head? Addition. It's like 2 and 2. You've heard people say that. It's really 2 plus 2. This is really 3 plus 1/3. The reason I highlight this is that once we're in algebra, remember this? 2x. What does that mean? And 2 times x. So in old-fashioned arithmetic, when you squeeze two things together, it means add. In algebra, when you squeeze two, well, at least a letter and a number together, it means multiply. That can get confusing. This, by the way, is why you do not do this. We never write it as 2.5x. At least I've seen it every once in a while, but in very, very bad form. Why? Because this squeezed together means plus, and this squeezed together means times, which is very confusing. What I would do is change this to a mixed number, or sorry, to an improper fraction, and make it 5/2x. So nobody has to worry about it. Does that make sense? So, this is a mixed number. I just wanted to highlight the fact that there's an invisible plus sign. Right? Now, the one over here is going to be a teeny bit different from that, but close. 2x plus 3 dividing into 4x squared plus 7x plus 9. It should have a haunting similarity to this. There's good news and bad news about this. Bad news is, look at all the x's. That usually scares people. They look at this and they think, it's annoying, but we can do it. This one, they start breaking into a cold sweat, saying, Mom, can you pick me up? This gets a little scary, but it's the same technique. Watch this. Over here, the way we started this whole mess, does a 2-digit number go into a 1-digit number? The answer is no, it doesn't fit. Does a 2-digit or 2-term number go into a 1-digit return number? No. There's a phantom 0 here. Does that make sense, Summer? All right. Now, 2 digits do go into 2 digits, so 2 terms go into 2 terms. just like 23 goes into 47, how many times, remember what your brain does. Because eventually you got so good at the times table that you do 23 times 2 and you know that off the top of your head, it's 46. But pretend you don't know that yet. So you had to have your brain make a guess. Look at the first and the first. The first number. That's all your brain does. Ignore everything else. Ignore the 3, ignore the 7. And over here, ignore the 3, ignore the 7x. Just the first into the first. How many times does 2x go into 4x squared? Over here, people thought I was silly for saying, how many times does 2 go into 4? I don't know, let's find out. And I did it. I said, crying out loud, if you don't know how many times 2 goes into 4, what are you doing teaching the class? But over here, it's a little harder to see. How many times does 2x go into 4x squared? I honestly don't know. Let's find out. Do the division. 4x squared divided by 2x. Every time I do that, step me through that. Eric, come in.
Could you repeat the question?
What is this? Reduce it for me.
2x.
2 and x, correct. How do you get a single x? Actually, that's a good question. How do you get the 2?
It's just 2 divided by 4.
Yeah, 4 divided by 2. But yeah, the 4 divided by 2 gives you 2. How do you get x? You're right, by the way. Why isn't it like x to the second power or x to the third power? Go for it.
You divide 2 by 1.
Well, 2 divided by 1 is 2.
1 divided by 2.
1 divided by 2 is a half. By the way, good try. I'll show you. By the way, can you tell me what, actually, Jenna, can you tell me what's x squared the long way? What does it mean?
X
X times x. What happens when you have x times x over x?
Yeah.
What do you think? What is that called?
It
Sorry?
cancels.
Yes, cancels. You have a single x left. These two make sense. Does it make sense? So, how many times does 2x get to 4x squared? I don't know, let's find out. 2x times. That seems a little strange to say, but put 2x up here. Put it back in. Righty. Rob, take it over. What do I do with this 2x?
You multiply it by 2x.
Correct. I'm going to multiply this here, but I got to do them one piece at a time. Tell me, what's 2x times 2x?
4x squared.
Next, 4x squared. The 2 times 2 is 4, and the x times x is x squared. Plus what?
6x.
Good, 6x. What do I do to this row?
Add the opposite.
Ah, good catch. Subtract, but add the opposite, really. Add how many opposites? 2. Add the opposite. You treat them like little single-digit math problems. All right, take over if you would. Mary, what's this going to give you? 0. 4x squared plus negative 4x squared is 0. What's this? 1x, or just x, whichever you want. Is that right so far? Keep going. What do you do?
Bring down the 9.
Bring down the 9. This, I will say, is going to be a little bit different. Take a deep breath. It's going to be a little strange. It won't hurt you much. I'll show you. How many times does this go into this? This is the part where it's a teeny bit different from here. Again, there's good news and bad news. The good news is, in this type of, well, the bad news is there's a bunch of variables. The good news, I was saying this at the beginning of the hour and I didn't even tell you the good news. Shame on me. The good news is that you will never have to borrow or carry ever again with x's and x squared and such. People are saying like, what do I do? Like, do I carry the 1 or something? Never. Never ever again. I mean, if you're doing numbers, yeah. Now, hang on to your hats. This is going to get, the fur is going to fly. That's a metaphor to watching cats fight. So, How many times does 2x go into 1x? What's the answer? Let's see who remembers. What do I always say at this point? I don't know. Let's find out. This, you will be thankful. This will save your bacon. 1x divided by 2x. That actually has an answer. It's a weird answer, but it has an answer. So, give me a checker. What do you think? What's 1x over 2x? What happens to it? Yes, the x's cancel, and you have 1/2. For the first time ever, you're going to put the number 1/2 as part of your answer. That is legal in these things. See, I don't see any blood or limbs lost, so you're okay. What do you do with the one? As soon as people realize what I'm about to ask, question or no stretching. Oh, okay, sorry. What do you do with the 1/2? Times it by what?
2x.
Yeah, by 2x and by 3. Take a deep breath. What's 1/2 times 2x? Doesn't that strain the brain? I'll show you a trick. I can probably do it here. 1/2 times 2x. This is actually something called math language. I usually teach this when I teach pre-algebra. Math language, I don't know if you realize math is actually a language. You can translate other languages into math and math into other languages. Quick question, it's probably pretty easy to get. Can you tell me on the average, what is the least popular type of math problem ever? Like historically speaking, throughout the ages, people have hated these types of problems with a passion. They look at them and they say, oh no. Like, 3 squared, nobody has a heart attack over that. I'll give you an example, yeah.
Division.
What's that?
Division.
Division? Actually, no, it's depending. Like 10 divided by 2, nobody's gonna lose any sleep over that. I will grant you, there are some division problems that'll scare people for weeks, but yeah.
Is it square rooting? Like
Square rooting with icky numbers, that's better. People can still square root, especially if they have those evil, icky boxes called calculators. Yeah. Fractions, good guess. A lot of people hyperventilate when they see fractions. But it's a general type of problem. I'll give you an example. A train is heading east at 30 miles per hour. Yes? Word problems, story problems. Like, has everybody heard of, it was a cartoon called The Far Side? I don't know if they make them anymore.
Oh yeah, I love that.
It was like this guy, it's by a guy named Gary Larson. If you can look up old, they're in the library. You can, not this library, but at the public library. They're like book, it's a comic strip. And The Far Side was the name of the comic strip. And they would have these bizarre stories. They were usually pretty funny. One of them was, the caption was, Hell's Library. And there were these people looking really wide-eyed and depressed. And all the books were saying, the big book of story problems, even more story problems. Wow, more story problems. And it was just crying. So anyway, I understand. People hate story problems. There's a reason why. They're in English. I mean, or Spanish, or whatever you're in. They're not in math language. If you translate a story problem into a math formula, they're not as scary. Now, the reason I brought that up, the word, just as a sample, the word is, it's an English word. Can anybody tell me what that means in math? Like x is 5. Go.
Equals.
X equals 5. The word of means something in math. Yeah. Times. Very good. Of means times. 1/2 times 2x, if you put it in English, is 1/2 of 2x. So what is half of 2x? Yeah.
Very good.
Yes, actually, I'll earn your bathroom. What's half of 2x? Just off the top of your head.
1x.
Exactly. Okay, that's your. By the way, you don't have to pay to go to the bathroom. That's good timing. So 1x. So half times 2x is 1x. half of 2x is 1x. It's the exact same problem. I mean, you do have to use common sense. If you're talking about the Duke of Earl, it's not Duke times Earl. You know, it has to be a math problem. But of doesn't always mean times, just in math problem. But we got this settled. 1/2 times 2x is 1x. Okay, math whizzes. John, you're on. What's 1/2 times 3? How do you multiply a fraction times a whole number? How on earth?
You just, I mean,
Yeah, go.
I don't really know how I don't know, I just do it.
Well, talk me through it.
It's 1.5.
You're correct, by the way. How do you get that?
I just, 1/2, two halves equals a whole.
Ah,
and
yes.
A half equals a whole and a half.
In other words, you put 3 over what?
3 over
What number can you put it over without messing up the 3?
2.
That'll mess it up. But what number can you always divide by and what? I thought I heard it. Okay. What number can you divide by and not change the answer at all? There's only one number on earth that is
1.
1. So watch this. You multiply straight across. 1 times 3 is 3. 2 times 1 is 2. And that's 3 divided by 2, which by the way is 1.5. I'm going to leave it as 3 over 2. Put that here, please. See what I just did? 1/2 times 3 is 3 over 2. That's the whole reason I did that, to find a number here. Okay, math whizzes. One last shot. What do you do with that row? Maria, you're on. What do you want to do with this row? Ah, very good. How many opposites? 2. What's 1x plus negative 1x? 0. Oh, funsies. How do you add fractions? Yes, 9 over 1. And now we need to find a what? To add any fractions, you need a, starts with a C. 2 words. Common, ding, 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 ding. Common denominator, like what? What denominator would be good for to handle 2? 9 over 1 is really what over 2? No, that's something else. There you go. Very good. 18 over 2. So it's 18 over 2 minus 3 over 2. Rosie, finish it out for me.
15.
Over 2. Bingo. That, math aficionados, which is a Italian word for people who are good at it. What do you do with it? What is that? It's the what? Oops, I wasn't pointing at the right spot. Yeah, it's the remainder. What do you do with the remainder? Go. Put it over this thing. This is totally funny. People think math isn't funny. Try this. 15 halves over what? Congratulations, you're done. By the way, if you can do that, you can do pretty much any problem I give you on the test. That's actually harder than any of the questions I will give you on the test. I will probably not have fractions in your quotient. You definitely won't have fractions in your remainder. And it's actually considered kind of rude for me to leave a fraction inside a fraction. It's kind of the social equivalent of leaving your dirty socks in the middle of the floor. It's rude. So it's like, Mr. Geiger, you left a fraction inside a fraction. Fine, I'll go pick them up. So, questions so far? All right. How much time do we have? I'm going to do 5 more minutes of this, and then I'll give you some time to work. Let me clean this off here. Isabella, I apologize profusely. You're going to be looking through the skyscraper. You can feel free to scoot over if you need to.
I can see.
Okay. That works. You're your own. Now, watch this. Go ahead and write that down. Last problem of the day. X squared plus 3x plus 4 dividing into 3x cubed plus 5x squared minus 7x minus 9. Okay, write that down real fast. Boop, boop, got it. We got some water. That's a lot bigger than the one we tried last time. Now, the good news is there are not going to be any fractions. I made sure of that. Everybody got it? Where on earth do you start? Go. Absolutely. You read my mind. Add the opposite, add the opposite. No subtraction sign will survive. Massacre. I'm not a violent person. Just saying again, just for the record. By the way, when we finally get to the, there's a chapter later on where we're talking about doing like massive common denominators. I have a metaphor called the machine gun method. Just warning you ahead of time. It's not something I do in real life. I don't go spraying people with bullets. But, just saying. I think that's chapter 12 or something. Where do you start after that? How do you start dividing? This thing is a monster. This is like a 3-digit number. Yeah. Exactly, it has to go in 3 digits. Can 3 digits go into 1? No. There's a 0 here. I'm just going to put a phantom 0. So you don't really need it. Andy, can 3 digits go into 2? No. There's another 0. So you're actually half done. Congratulations. Eric, help me out. Can 3 go into 3?
Yes.
Yeah. How do I know what's supposed to go into what? Do I do like 3x into 3x cubed, 4 into... What do I match up? Second, I'm sorry? Oh, sure. In other words, how do I know? I want to know how many times this goes into this. But there are like 3 terms going into 3 other terms. How do I start? Where do I pay attention to? You're only supposed to pay attention to 2 of those.
The first.
The first and first, second, and third.
First.
The first and the first. That's always what you look at. That's only what you look at. Catherine, take over. How many times does x squared, I'm going to see if you remember my answer. How many times does x squared go into 3x cubed? What? What do I say? Yeah, I don't know. Let's find out. Do 3x cubed over x squared. Now, Catherine, help me out. How do you do this? What invisible number is in front, by the way? 1. Do that first. Do the numbers first. What's 3 divided by 1? 3. What's x to the third divided by x to the second? Second? It's 3x. Exactly. Look over here. X cubed, if you ever get stuck on these power problems, write them out the long way. 2 pairs of x's cancel, and only 1 is left. So excellent. Excellent. So we've got 3x on top. I didn't even realize I was going to say that till I grabbed it. 3x. What do I do with it? Let me see. Rob. What do I do with this 3x up here?
Multiply x squared plus 3x plus 4.
Do it, one term at a time. What's 3x times x squared?
3x cubed.
3x cubed, good. Keep going. 3x times 3x?
9x.
Yeah, 9x
Squared.
squared, good. Plus 3x times 4?
7.
Multiply that.
Wait, 12x.
Good, 12x. Everybody right so far? Jack Gilbert, take over. What do I do with this row? Nice. Add the opposite. How many opposites? 3. Watch this. Subtracting the whole row is adding the opposite, opposite, opposite. Do them one at a time. John, take over. What's this going to be?
Nothing, 0.
0, exactly. What's 5x squared plus negative 9x squared?
Negative 4.
Good. Negative 4x squared. Nice. Power doesn't change. What's negative 7x plus negative 12x?
Negative
They join each other.
Oh, negative 19x.
Nice. And then what do you do with this?
Leave, bring it down.
Bring it down, good. We're done with the first cycle. Everybody okay? Okay, Mary, take over. What do you look for next?
Look at the first term,
First term, exactly. How many times is x squared going to negative 4x squared? I don't know, let's find out. Negative 4x squared over x squared, what does that actually give you? Go ahead, Mary.
negative 4x.
Hello?
Oh wait, negative 4.
Just plain old negative 4, because the x's cancel completely. 2 x's on top, 2 on the bottom. So put that up here. By the way, always put pluses in between everything. Plus negative 4. That's gonna be fun. Rosie, take over. Give me that one on steroids. Sorry.
Negative 4 times x squared plus 3x.
Correct. Do that one at a time.
Negative 4x squared.
Good. Plus.
Negative 12x.
Yes.
And then negative 16.
Nice. All right. So, Josh, take over. What do I do with this row? What do you do with any row that's this second row? Kind of like, I erased it, darn it. Yeah, let me do it real quick. Sorry if I'm off. I'll just do it down here. Remember this 12 goes into 379? This was like a 3 and this was like 36. What do you do with this?
You make it so that you can add instead of subtracting.
Correct. Instead of subtracting, you add the opposite. Do that here. Instead of subtracting, it's really adding the what again? Opposite. What's the opposite of negative?
Positive.
Everybody look up here. Catch this. Subtracting a negative, adding the opposite, opposite, opposite. This is an addition problem. Go for it. What's negative 4x squared plus 4x squared?
0.
Exactly. They cancel. 0. What's negative 19x plus 12x?
7. Negative 7.
Good. Negative 7
X.
x. Nice. Plus, what's negative 9 plus 16?
Plus 7.
7.
Positive.
Exactly.
Positive.
Quick question. Oh, math. Folks. I cannot let that stand. Hang on. Finish this off. Mia Jackery. What is this thing? It's the remainder. How do we know we've gotten to the remainder? This is a 3-digit number, and there's no way it can go into a 2-digit number. It's too small. We're done. What do we do with it? Yes, put it over this monster. There's something I would put right before it, though. Addition sign. Plus, and everybody please copy this down, negative 7x plus 7 over x squared plus 3x plus 4, and congratulations, you just did a relatively big long division problem. Yeah.
Are we ever going to have to reduce?
Oh, are we ever going to have to reduce this thing? The short answer to that is, in real life, yes. As far as our test goes, probably not. It's probably going to be like this, where like there aren't any 7s on the bottom. You don't have to worry about it. This we would have to reduce. This was just a total monster. This was harder than I intended. But trying to think of the short answer is no. You don't have to worry about it. In the real world, in the wild, so to speak, there will be some way you do. I'll show you those later. After chapter 10, I'll be able to show you that. Questions? All right. So you still have one more multiplication homework. That's homework 9E as in Egbert. I would like that to do for tomorrow. You are welcome to use the rest of the hour. You may work in groups if you are quiet. Yes, ma'am. I'm I'm sorry, which? Oh, did I check off 9D? Oh, I'm an idiot. Okay. I'll tell you what, while you're starting to work, thank you, you saved my bacon. Put out your 9D as in David. Actually, no, I'm just gonna do that tomorrow. Because then we have to go through the answers too. So hold on to 9D. Yeah, that's right. I kept thinking it was still Wednesday for 9D. I thought it was already done. We'll just check them both off tomorrow. So 9D and 9E. So we'll, if you need a little extra time for 9D, congratulations. So we'll check both of them off, read the answers off tomorrow, and go from there. All right. And for those of you listening at home, God bless. See you later. By the way, click like and subscribe on my channel. Okay, sit down.
God, they don't want to see it.